Article 506.17(1) states that equipment must be of a type listed for extra-hard usage. Firstly, listed in this context does indeed refer to the definition in Article 100 of the National Electrical Code, or NEC. This means the equipment in question must be included on a list published by a qualified testing laboratory. Examples of such laboratories include Underwriters Laboratories, often referred to as UL, or the Canadian Standards Association, known as CSA. These organizations rigorously test equipment to ensure it meets specific safety standards and performance criteria. Secondly, the term extra-hard usage is not explicitly defined within the pages of the NEC. However, in general electrical engineering practice, it refers to applications where the equipment will be subjected to severe mechanical stress, vibration, or other harsh environmental conditions. Think of environments where equipment might be constantly bumped, moved, exposed to intense vibrations from machinery, or subjected to extreme temperatures or corrosive substances. Now let's discuss wiring methods. Using power-limited tray cable, often abbreviated as PLTC, with cable glands at both the field device and the junction box is often an acceptable method for wiring between field devices and junction boxes in Zone 22 locations. However, this is contingent upon meeting several crucial conditions. The first condition is that the PLTC cable itself must be suitable for extra-hard usage, as previously defined. This means the cable's construction must be robust enough to withstand the anticipated mechanical stresses and environmental factors present in the Zone 22 location. The second condition is that the cable glands used to terminate the PLTC cable must be specifically listed for the type of cable being used and for the particular environmental conditions present in the Zone 22 location. Not all cable glands are created equal, and using the wrong type can compromise the integrity of the cable termination and potentially create a hazard. The third and final condition is that the cable must be properly supported and protected throughout its entire run. This means ensuring the cable is adequately secured to prevent excessive movement, strain, or abrasion, and that it is shielded from potential physical damage. It's also important to consider the installation environment. In some cases, additional protection measures, such as conduit or mechanical guards, may be necessary to ensure the cable's long-term reliability. To answer the question of cable trays are not strictly required for short runs of PLTC cable in Zone 22 locations, provided that the cable is properly supported and protected. However, cable trays may be required for longer cable runs or in areas where the cable is exposed to a higher risk of physical damage. The decision of whether or not to use cable trays should be based on a careful assessment of the specific installation conditions and the potential hazards present. When considering the appropriate wiring methods for Zone 22 locations, it is crucial to consult with a qualified electrical engineer or other expert who is familiar with the requirements of the NEC and other applicable standards. These professionals can help ensure that the wiring system is designed and installed in a manner that is safe, reliable, and compliant with all applicable regulations. In summary, selecting the appropriate wiring methods for Zone 22 locations requires careful consideration of several factors, including the type of equipment being used, the environmental conditions present, and the requirements of the NEC. By following these guidelines and consulting with qualified professionals, it is possible to design and install a wiring system that is safe, reliable, and compliant. Let's dive a bit deeper into the technical aspects of selecting PLTC cable and cable glands for Zone 22 applications. When choosing PLTC cable, it is essential to consider the cable's construction and materials. The cable should be designed to withstand the specific environmental conditions present in the Zone 22 location, such as extreme temperatures, exposure to chemicals, or the presence of dust or moisture. The cable's insulation and jacket material should also be selected for their resistance to abrasion, impact, and other forms of physical damage. In addition to the cable's physical properties, it is also important to consider its electrical characteristics. The cable should be rated for the appropriate voltage and current levels for the application, and it should have adequate shielding to minimize electromagnetic interference. When selecting cable glands, it is important to choose a gland that is specifically listed for use with the type of cable being used. The cable gland should also be rated for the appropriate environmental conditions, such as extreme temperatures, exposure to chemicals, or the presence of dust or moisture. Cable glands are available in a variety of materials, including metal and plastic. Metal cable glands are generally more durable and offer better protection against physical damage, while plastic cable glands are lighter and more resistant to corrosion. Choice of cable gland material will depend on the specific requirements of the application. Proper installation of PLTC cable and cable glands is essential for ensuring the safety and reliability of the wiring system. The cable should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. Cable glands should be properly tightened to ensure a secure and watertight connection. The cable should also be properly supported and protected throughout its run to prevent damage or strain. In addition to the specific requirements for PLTC cable and cable glands, there are also general wiring requirements for Zone 22 locations that must be followed. These requirements are outlined in Article 506 of the NEC and other applicable standards. Some of the key wiring requirements for Zone 22 locations include the following. All wiring must be installed in accordance with the NEC and other applicable standards. All wiring must be properly grounded to prevent electrical shock hazards. All wiring must be protected from physical damage. All wiring must be suitable for the environmental conditions present in the Zone 22 location. All electrical equipment must be listed for use in Zone 22 locations. Regular inspection and maintenance of the wiring system are essential for ensuring its continued safety and reliability. The wiring system should be inspected periodically for signs of damage, such as cracked or broken insulation, loose connections, or corrosion. Any damaged wiring or equipment should be repaired or replaced immediately. It is also important to ensure that the wiring system is properly cleaned and maintained to prevent the buildup of dust, dirt, or other contaminants. In addition to the technical aspects of wiring Zone 22 locations, it is also important to consider the human factors involved. Workers who are involved in the design, installation, and maintenance of wiring systems in Zone 22 locations should be properly trained and qualified. They should also be aware of the potential hazards associated with working in these locations and the proper safety precautions to take. By following these guidelines and best practices, it is possible to design, install, and maintain wiring systems in Zone 22 locations that are safe, reliable, and compliant with all applicable regulations. The importance of understanding the definitions and requirements outlined in the NEC cannot be overstated. It provides a framework for safe and reliable electrical installations, particularly in hazardous locations such as Zone 22. The NEC is a living document that is updated regularly to reflect changes in technology and best practices. It is essential for electrical engineers, electricians, and other professionals who work with electrical systems to stay up to date on the latest requirements of the NEC. In addition to the NEC, there are also other applicable standards and regulations that may apply to wiring systems in Zone 22 locations. These may include standards from organizations such as the International Electrotechnical Commission, or IC, or local building codes and regulations. It is important to be aware of all applicable standards and regulations and to ensure that the wiring system complies with all requirements. Finally, remember that safety is always the top priority when working with electrical systems. Always take the necessary precautions to protect yourself and others from electrical shock hazards. Wear appropriate personal protective equipment such as gloves and eye protection, and follow all safety procedures. If you are unsure about any aspect of the wiring system, consult with a qualified electrical engineer or other expert.